Okay, so this is third class, and we're going to be building off of some more fundamental skills. So working with lists and records and sort of more complex kinds of data. So do we remember the sort of basic values that we had from first class or second class? There's one here. What are some other ones? We have numbers.
Let's see, there were variables.
Well, just the data holders. So a thing like a number or a string, yes. We didn't have a ton more. We had lists. Do you remember that?
Mm-hmm.
We got a couple things.
And objects? No, what did you call
No.
Elements.
Yeah, elements. Okay, so we have some core things, and the one we're going to focus on is lists. So these are interesting. They can hold lots of stuff, but so far we only know how to look at them, as opposed to actually go in and dig around and see what they're all about. Okay, so the first thing I'm going to introduce is a way to add things to a list. So add to front, x to x's. So this is like adding an x to a bunch of x's. You say that with x : x's. Okay, so it's a new operator, and it basically means put one on the front. So if we say here 0, put one on the front of this list, we'll see 0, 1, 2, 3. Okay, and so let's try to rewrite this list slowly using that same idea. So what's another way I can say 1, 2, 3?
X : 1 : 2, 3.
Nice. And again?
1 : 2 : 3.
Okay. Again?
1 : 2 : 3 : nothing.
Exactly. Okay, so we just made our list uglier and more confusing, but we did it for a good reason, because this is what every list actually looks like underneath the hood. So we have this nice syntax where we can put in brackets, but what we're really doing is creating this data structure. We say a list can either be empty, or it can be something that is the front of the list and the rest of the list. And so you can see how from those two things you can build up something of arbitrary length. So this is going to let us start taking a list apart. So we can start asking questions like, is empty list? So we can do this with our existing knowledge. How would we do this with what we know already? We have a list and we're like, is it empty? How would we say we have a number, is it 0?
Oh.
If number equals 0, true.
Okay, so this is a common beginner sort of way of writing things, because you can simplify it a lot. So you're saying, if this is true, then true. If this is false, then false.
But you already know how to do it. What is it? If true? No.
Well, so if you just say
Okay.
it's the same thing, right?
Because then we get true.
Exactly. Okay, so if we wanted to do it this way for is empty,
Equals just brackets.
So you can say, is it equal to nothing? So we can then say, is empty this whole guy? And then if we say, is empty. Okay, so this is not a good way to do it because it doesn't scale very well. Like, what if we want to write a function that says has one element. Right, so suddenly we're like, well, it equals a list with one thing, but what is that thing? So we need some new syntax in the language. So this is called a case expression, and it's able to look at the structure of some data and tear it apart based on what the structure is. So you can say if it's empty, then it is empty, and then you can say if it's x is. So if it is some element in the rest of the list, then we know that it's false. And so we can name these whatever we want. So like x and rest of the list, or one common one is head and tail. So like a snake kind of, and you're like chopping its head off, but then it's not a great analogy, but that's kind of the feel of it.
That little arrow mark, is that actually an operator or something?
That means
Then?
it's yeah. So you can read it as like, if I see this pattern, then run this one. If I see this other pattern, then run this other one. So another thing we can do here to make this a little nicer is you see we're not using head and tail, so we can actually put an underscore and say we don't it's matching something there, we don't care. So you're really just thinking about the structure of this thing. Does that make sense?
Yes, but sorry. That underscore, is that just a placeholder here?
Yeah, it's a special like pattern.
Okay. So it means kind of like an asterisk, like any.
Yeah, it just means whatever. I could give this name, but I don't want to because I'm not using it. And we can do even a little bit crazier here because we just really don't care at all what it is. If it's not empty, then it doesn't matter. So this is like the nice way to write it. I'll leave this here with names and stuff as we move on because it'll be helpful to have that as an example. So let's say we want to check if it has exactly one element. How would I start? You don't need the full answer, just like first letter, first word.
It's not empty and has no tail.
Yeah.
Right?
Yeah.
That was my part.
Okay, so when we're with these problems going forward, the first thing we're always going to want to do is probably case, because it's saying we have this list and we don't have any way to work with it. So case is like, okay, we're going to tear it apart and see what's inside. So what are cases?
So brackets false.
Okay.
And then head colons tail false.
Okay.
And then
Can you just do head?
yeah.
Head thing true.
Okay, so this will break. So let's run it though. So has one element. Okay, so that's the right answer.
Hey! Good job.
Don't celebrate yet.
Celebrate yet.
Okay, let's save this. Okay, so it worked with that, and it. Okay, that's correct.
Yay!
Okay,
No.
so something is bad here. So let's break this up. Let's rewrite this list in the other format. What is that again?
Colon. That
Can you
one, was it?
Head colon empty brackets.
And then what's our last case?
Head
Head
tail.
colon tail.
Okay, so let's try again. True. And then if we add things here, false, false, so on and so forth. Okay. So we can write this a little smaller if we want to. So when you try to pattern match, this is called pattern matching, you're going to go in order. So you're going to try this first, and if that doesn't work, then you're going to try the second one, so on and so forth. So do you have any ideas? How can we put more underscores in there and get rid of more code?
Well, you could just do the middle one. If it's head, colon, colon, empty, it's true.
Okay.
Else, false.
So what's this pattern?
Underscore.
Nice. So this is also a correct answer. And you can be a little fancy with the syntax, and you can say this.
Oh.
Yeah.
Anything inside the brackets works.
Yeah. This gets tricky though, so keep in mind that this is exactly equivalent to saying this thing. So if you do brackets and then colon, colon, other stuff, it's not exactly the same as doing colon, colon, colon all the way. So for example, let's say we have a list of lists. So we have 1, 2, 3, oops, and we have 4, 5, 6. Okay, so we have a bunch of things, and if we break this, these lists are too long. If we break this into smaller lists again, so if we do that same conversion, it'll look like this, and then this. And so you notice that we actually have lists part of the way along. And so if we were to convert those again, you need to put them in brackets to sort of distinguish that these lists aren't part of the
It's like a little inside quotes inside of big quotes.
yeah. And so if you were gonna, I shouldn't have gone into this whole spiel. The point is, a list of lists isn't, you can't just put colon, colon. You need some way to distinguish them. And so if you were to try something like this, it actually means the first element is a list of size 1, and then there's a rest of the list. Not, here's the first element, here's the rest of the list. Does that make sense?
No.
No, it doesn't make sense. Okay, yeah, this one,
I'm trying to come up with a situation in which this will be useful to me.
this is the kind of thing where when you're trying to program, you're going to run into this and be like, why is it not working?
Yeah.
And then you'll remember this moment and you'll be like, oh, okay, yeah. Okay, so far we're doing kind of lame things with lists. They can be arbitrarily long, and we're just seeing if they have nothing in them. So let's see how long they are, for instance. So we're going to take a list, and we're going to figure out its length. Okay, so what is the first thing we should do?
Length in number of elements or length in number of characters?
Number of elements.
You guys are on Prezi Public? Okay, and it's working?
It is?
The internet's not working today.
All those growing pains of new office.
Oh, it's really sad. I was copying and pasting between 2 Prezis, and then it just stopped.
Oh, that hurts.
I about cried. Yes!
Okay,
Nothing lost.
you're dodging the question here, which is what do we do first? We want to figure out the length of a list. We have a list, it might be empty, it might not be empty.
Well, the easy answer is if it's empty, then the length is 0.
Okay,
So
what should
case
okay.
list of empty gives you 0.
Okay. That's good. That's a good start.
Who's next?
It has one element. If it's the underscore in the brackets. Or that.
Oh, yeah. Okay. 1. Okay. You're doing good.
It's your turn.
Okay.
Now the arbitrarily long.
Now the useful verb.
Well, we can try to keep this pattern going, right? So we can say, well, maybe it has 2 things. We're going down a dangerous road here.
That's funny.
Do we have to make a function?
Well, yeah. So when you're writing a function like this, it's really good to like look at all the things that are available to you. So you know you have a list sitting around. You know you have length sitting around, which you can just assume is correct and use.
Mm-hmm.
And you know we can do some kind of matching on these things.
Mm-hmm. Okay, so each time you see underscore colon colon, you want to increment by 1.
Right?
Or,
Okay.
yeah.
So let me change the names of these patterns, and then we'll see where we can go from there. So instead of saying this, let's just call it head and tail. So we have the first thing in the list, and then we have the rest of the list.
Mm-hmm. So you want to count heads.
Okay, yeah.
And each time you cut off a head, you're going to count the next head to get rid of 1 of heads.
Mhm.
Right?
Mhm.
Okay.
Well, so think of this as, like, remember back here. So we have 1, and then we have this whole thing.
Mm-hmm.
So if you wanted to say the length of this list, just in terms of these 2 pieces, you have the 1 and you have the 2 through 2.
Yes.
How would you say it? So we have our head, we have our tail. Well,
I'm having trouble understanding how I can cut the head off the tail and then preserve the tail to go look at it as the next head.
well, we have the tail right here, so we can ask.
Just call it tail. Okay.
Yeah. So we're effectively naming that thing, so we can actually use those things
Okay.
in our
So
function.
head colon colon tail, then increment sum counter by 1. 1 plus length.
1 plus tail.
Length. 1 plus length of. I'm going to put those answers together. 1 plus length of tail. So we say, okay, I saw a head and a tail.
Yeah.
I know I have 1 because I saw the head. And I know that the length of the list, the remaining list, the tail, plus 1 is going to be the right answer.
Yes.
So now we have to define length of tail.
No, but we already did.
We did?
It's this whole thing. So
Yeah.
it's recursive, right?
Oh, I see.
Now will it run through itself until it runs out of.
Exactly.
Wow.
And then when you get to tail by itself.
Well, in the last case, you get to empty,
Okay.
and it says I'm 0. And then it goes plus, 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 plus.
Really?
Wow.
Nice.
Okay, so let's see if this works. I say it works, but who knows? I'm not a compiler. Okay, looks good. I remember this is with this list here. Okay, so if I do this one, what am I gonna get?
3, 2.
2,
Because the last bracket is a containing bracket.
right? Okay, so we've done well. So we can get the length of any list.
Wow.
Let's take the next step.
Awesome.
I'm gonna use that all.
Okay, numbers. So let's get the sum of a list of numbers. So what's the first thing we do?
So it would be brackets, the arrow 0. And
Okay.
And then head, colons, tail, arrow, plus one
Head,
or plus
head
Head.
plus
tail.
sum.
And are we missing anything? We're missing something.
Case. List.
Yes.
Oh.
Yeah, I changed it up.
Numbers up.
Changed it up. Okay, so does this seem right? Do we feel okay here?
We're copying the pattern we've seen before. It's a very comfortable pattern for us.
Okay, so it seems reasonable, right? We're taking everything in the list and adding it to the sum of the rest, which we are going to go compute. So when we say sum of list, we should get
6.
6.
Yay.
Okay, so we have succeeded.
What about sum of list of lists?
Would be 6 as well.
It would
If it works.
yell at us.
Oh.
Why?
Oops. So it's expecting. So down here, when we say head plus sum of tail, head is actually a list, and to say plus on a list doesn't mean anything.
Oh, so list of lists is, as it's named, a list of lists.
Exactly.
And you can't, this isn't the sum of a group of lists.
Exactly.
This is the sum of a group of numbers in a list.
So
Exactly.
you have to actually run the sum of the internal lists before you.
Yeah.
You have to
In
use
fact-
Oh man. Wow.
How fancy.
Okay, so let's say we do want to do that. We want to get the sum of a list of lists.
You'd have to make, would you have to turn each list within the string of lists into like a variable? That's basically cool.
You could perhaps do it that way, but let's go with our tried and true technique.
Break it apart
Exactly.
and then run it on each one.
Yeah. So should I type that out, or do you want to?
I would copy the one above it
Okay.
and then add something in between case numbers of and brackets here.
Case. You'd add something here.
Right, yeah, right in there, there's something to break the list into. How do you pull them apart again? Head and tail. So,
Okay.
I want just the head.
Okay.
I've named the head, now it's head.
Well, we needed some, right?
Yes. Head, if it's head and tail, and I want to take the sum of head, then I can turn head into sum? No, I can't get it.
Yeah, you can just sum it. You can just say, I want the sum of this thing. And then I want,
To do that again and again.
in this case, the bottom case isn't what we want. So it does look quite similar, except we're changing things around. Does this make sense?
I think so.
So I think it'll be easier with nicer variable names. So if we have numbers is to mean a list of lists of numbers, then we have numbers, and then we have like rest of numbers.
Well, we already have numbers up above.
Number lists.
We've got one time with S's, one time without S.
Wait, say what?
Numbers list.
Sum
Oh.
lists, numbers lists.
Yes. Okay. And so the first thing is going to be a list of numbers, and the second thing is going to be more
More
number lists.
numbers.
So we want the sum of these numbers, and then we want the sum of the rest.
And it's not going to bother this one and the one above it, is the sum of numbers.
What do you mean?
Directly above it.
Yeah.
So it doesn't matter that numbers is already being used.
Oh, this numbers?
Yeah.
Yeah, so each one is local to the sort of
Okay.
the thing on the other side of the equal sign. So
Okay.
this list is only in use in this part, and this
Okay.
number is
So you
only
can
in use
use
here.
list again and again and again.
Yeah,
But that means
exactly.
you can't create something from list and then use it later as that list.
I'm not sure.
If I was using list up there
Mhm.
and then later I wanted to call the result of that down here as list, I would have to create it.
You might need to it's bad policy to have overlapping names.
Mhm.
So what you can do when you want to use the same variable again is you can add a prime to it, and it's a different name, but you can name it however you please.
Okay.
Okay, so we got a mistake when we tried to sum a list of lists. So let's try, what do we call it? Sum of lists. And we get 6. Okay. So, all right. This is a good start for lists. There's lots more cool stuff we can do. So as you guys probably noticed, we started repeating ourselves a lot. We started seeing a lot of code again and again, all these expressions. We can pretty much factor this all out and write all these things that we wrote in like one line. But it's outside the scope of this class. We'll have future classes on this. It's really fun. I get like weirdly excited about this stuff. Okay, but so instead of going deeper with lists, we're going to go for a different data structure.
Will that
So
make it faster? Not to write, but to run.
perhaps in that if you write the more general version really well, then you don't have to think so hard when you write the uses of it.
I guess I was just thinking that kind of optimization where you get all that code down into one line. Does that make the program run faster?
Oh, I see.
In terms of optimizing.
It depends. It depends. So lots of yeah. If the compiler doesn't do any tricks, it should be slower because you're actually calling more functions to get where you want to go. But if the compiler is clever, it's able to say, oh, when you say that, you actually mean this thing, and you actually mean and do a lot of rewrites to sort of crush it down. Okay, so there's another data structure. We can deal with many things, like arbitrary many, but we can't deal with kind of like structured data. So let's say we want to represent a student. So we have a thing called a record. This uses the curly braces. You can say name is Evan, and let's take me in 9th grade biology class, okay? And we have my
That
grades.
was last year, wasn't it?
And I wasn't great at biology, but like I did all right. But there was one time in this class where we're like waiting to go into the classroom and someone's like, are you ready for the quiz today? And I was like, ha, what? And we were studying like the different positions on the body. So like anterior, posterior, dorsal. So basically like, obviously I don't know those
So
things.
vocabulary.
Yeah, so I'm just like frantically looking at the sheet. I'm like, and then go in and I'm like, so that was one of the quizzes. So yeah, so we have a bunch of grades, and maybe there are other things like, essentially we can put as many of these fields in as we want. So we can say,
Student ID or something.
yeah, ID. And so when we want to look at these things, let me grab main away from here. We can say main equals as text of student dot name. so we can go and access those things.
How come we came out with 6?
Say it again.
Oh,
Or grades. Ah, I forgot the best part of the lists thing. Okay, one moment. And so we can look at any of these things. So student ID. Okay, now I say I forgot the best part of the list thing because I wanted to get my average for the class. We didn't write average yet. Okay, so
I thought you were saving that as a surprise.
no, I forgot. So we have a bunch of numbers and we want to do something with them. So what's your intuition?
Gotta take the sum of the list and divide by the whole thing.
Oh, 2 things we just happened to have already done. Very nice.
I feel like you said this, but this isn't what you actually meant necessarily, or did you mean write this code?
Oh, no, that's
Oh,
what she said.
that looks pretty good.
Okay, yeah. The idea here was to trick you guys into trying to write the case and then slowly remind you that we'd written both parts of this already and then show this nice equation and be like, how can we do it? How can we figure it out? But instead, I just assumed that that's what you're saying and I
Actually,
skipped.
in my mind, I had pictured writing that whole case, and I'm so glad that he jumped right from
But so this is a good point though, in that the right intuition is to go for the case. You do need to break it apart. But you need to balance that with this question of like, am I rewriting something I've written before?
Yeah, what do you already
And so always keep in your mind, I do have something that does. Yeah, exactly.
Yeah.
And so when you start seeing something familiar, you want to look back or look at documentation and see. So now when we want my grade, let's see if I can still get a nice grade in this class. When we want my average, how do we do that?
Average grades equals.
As text.
Well, average grade.
Equals average student dot grade.
Okay, let's see.
Ooh.
Okay, so that's pretty bad. I'm pretty sure I got a B in this class though.
Quizzes don't count
I
for that
got
much.
it in
You need a
biology.
weighted average.
Yeah, exactly. So how could we make this a function? Say we have more students. So we have Evan, and he's got a name and some grades. And then we have more people. Tom, name equals Tom. Grades. He kind of was a funky. He didn't really go to class very often. But he did all right sometimes. He also didn't study for the same quiz I didn't study for. And then he was like, we got to turn this around. And I don't think this is going to work out for him. But so let's say we want like, oh, okay, even better. Now we have a couple students. Maybe we also have a representation of a classroom or a teacher.
Class average. Something like that.
Exactly. We could do something like this. So how would we represent, say, a teacher? So we have someone who has a name, who has students, who has,
Name
I don't know, a
equals-
class name.
Oh, sorry. Curly bracket. Name equals.
What's a good famous teacher?
What's the guy from Hogwarts?
Oh yeah. Oh wait, can I be in Snape's class? Snape.
Students equals.
Bracket, Evan, Tom.
Evan and Tom, very wizardly names.
Oh, Draco's actor's name is Tom.
Like they
Planned it.
Yes.
Planned it. I'm sure there was some extra in the movie named Evan.
I can find out.
So let's say, okay, this will be trickier. But so now we are able to talk about sort of more complicated kinds of things. So let's say we want to get the average grade for a particular student. Right now we're calculating it for Evan. But let's say we want to do it in general. How do we do that?
Well, I guess you could create a variable called student. Oh, because you have students. So can you reference students? And then it'll include Evan and Tom.
Students dot grades.
Teacher dot students.
Well, so let's see what happens here. Okay, so it doesn't know what students is. So students can only be accessed by saying teacher dot.
Mm.
And we're going to have problems again because we're giving it,
We have to
Someone
do a
with
sum of
certain
the
names.
list of lists.
and it's expecting, yeah, we need to do some more
We
complicated
have to
things here.
create average for a list of lists, right?
That's one way to do it.
Actually,
So,
I think you changed the question.
Oh, what's the question?
It's the general case of an average for a student rather
Yeah.
than calling a student.
I thought we wanted the average of all, like the class
we'll
average.
get there. We'll get there. Yeah, because this is a sub piece of that.
Yeah, like a general. That makes sense.
So would you go and create one that says students equals Evan, comma Tom, and take it out of teacher?
Well, so we just want basically a function that's going to take a student and give us back that student's average. That make sense?
But we already had that. We
Well-
just had it named Evan instead of having.
Right, so we had this version,
Right.
which works, but it's only for Evan. So like if we want to run it on Tom and Harry and Lucius and all of these other,
So
People.
change the
Lucius
word
wasn't in
Evan
the class.
to student,
okay,
and then at some point you have to ask who's the student.
right. So we need an argument
Yeah.
to this function. So basically saying average grade takes a student and then figures this out. So we can say average grade Evan. Tom, I don't think we've seen his average yet. Yeah. Tom. Okay, so we have a function that will get the average for a student. But what if we want class average? And we'll say it takes a teacher. And again, this teacher here is just in scope in the next thing that we write. So we can have this teacher name and it doesn't conflict. Does that make sense?
Mhm.
Okay, so we have a teacher.
Snape.
Snape, exactly. Oh yeah, I should name him Snape. And we want to work with the students.
So you would say teacher dot students.
That's what teacher's gone. No, it's Snape.
No. So
No,
we're
this is just for
Oh,
that.
sorry. You write the function and then you invoke the function later.
right, exactly.
Sorry.
Teacher dot students dot grade.
Well, so students is a list.
Right. So that's problematic.
So I'm going to show you a new
We
function.
worked with that list of lists before.
Yeah. I'm going to show you a new function. It's a handy dandy one that comes in helpful here. Okay, so it's called, all right, we'll just see it in action and then I'll explain. So you can say map square root onto 1, 4, 9, 16. And it basically says take this function, square root, and apply it to everything in this list and give us the new list.
So we could do map average teacher dot students dot grades.
Oh, we need their grades.
We need their grades.
Well, let's look at the functions we've written already.
We have average grade student.
Right?
So, yeah, that sounds good.
Because you have a list of students, and we want to take each student and get their average. So we have a function that does exactly that thing. And then when we want the class average, so right now we have a list of average scores. So we know Evan got a 76, Tom got a 60 something or other.
So we have a list.
Exactly.
So we have to do sum of the list.
Well, so that would,
And then, no, we can take an average of the list because we have, yeah, okay.
okay, so let's see what happens here. What's unfortunate with this example I didn't think it through is that we can't really verify unless we do the math ourselves.
As long as we don't get an error,
We'll call it good.
we'll get a laugh.
It was about right.
It's
It was,
wrong.
Did you do it in your head?
No, but so Tom had a 59
Mm-hmm.
and you had a 75. I guess that is right.
76.
So Snape is doing pretty badly. Or rather, Snape teaches a hard class.
Well, Snape was a jerk, so.
He just needs to adjust his curve.
Yeah, exactly. We aren't going to write that function,
And
unfortunately.
you guys were in Gryffindor, he hated you guys.
So yeah, so we have lists. We can work with them in various ways. I have some really great challenge questions for the lists. I'm personally very excited about them. Hopefully you'll give them a try, and if you fail, come talk to me about them because it's going to be awesome. But yeah, so we have lists and we have records. So we have this structured thing, and when we put these together, we actually can start to describe fairly complicated things in the world. So we were able to describe Snape, which when we had numbers and strings wasn't really within the realm of possibility. And so you can imagine when we start working more with graphics, maybe you're representing like a teacher graphically, or you're representing a warrior and he has health and he has a position on the screen and all these things. We now have those tools because we can just say, okay, this dungeon monster has this position, he's this level of angry, he has this much health. We're using a record. And then we can have a bunch of them, we can have a list of them, they're all swarming around. Okay, and then we can mess with the list and move them around. So we're really building the foundation here. Okay, yeah, so that's the basics of data structures.